Good evening all. Now I would like to discuss about maximum power transfer theorem theoretical calculations. Okay, in case of maximum power transfer theorem also, to calculate load current, here I have to use Thevenin's theorem only. Okay, see already we know that in case of Thevenin's theorem, to calculate load current, first we need to calculate Thevenin's voltage, right? To calculate Thevenin's voltage, step 1, remove the load resistance RL. Okay, remove the load resistance RL across those two terminals. I need to calculate Thevenin's voltage or open circuit voltage, right? Under open circuit condition, current I is equals to 0, right? Then here V Thevenin's is nothing but this total voltage is applied across the 1 kilo ohm resistor. That is nothing but V Thevenin's is equals to voltage across 1 kilo ohm. Now see here no current is flowing through this resistor, right? That means total is a series circuit. Okay, by using voltage division rule, I can calculate voltage across this 1 kilo ohm resistor. That is V Thevenin's, that is equals to voltage across 1 kilo ohm, that is equals to total voltage into that particular branch resistance, that is 10 volts into 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm. I will get V Thevenin's value as 5 volts. Okay, next step 2. In case of Thevenin's theorem, the step 2 is across A and B terminals, we need to calculate Thevenin's equivalent resistance. Okay, while calculating Thevenin's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit. Okay, now see here from this equivalent circuit, here 1 kilo ohm and 1 kilo ohm, these two are connected in parallel, right? When two equal values are connected in parallel, that is 1 into 1 by 1 plus 1, resultant value will be half, that is 0.5 kilo ohm. After that, this resultant value is in series with the 1.5 kilo ohm. Then the Thevenin's equivalent resistance will be 2 kilo ohm. Okay, after that, draw the Thevenin's equivalent resistance. So draw the Thevenin's equivalent circuit, that is VTH from step 1, RTH from step 2, and load resistor which is removed from step 1. Okay, we can add here load resistance value I am using 024 kilo ohm. Then load current formula will be IL is equals to VTH by RTH plus RL, right? That is VTH value will be 5 volts, RTH value will be 2 kilo ohm, RL value is variable. That means here I need to vary this RL value from 0 to 4 kilo ohm in steps of 200 ohms, that is 0.2 kilo ohm, and calculate load current. Okay, after that we need to calculate load power, how much power is delivered. Okay, how much power is delivered from source to load. The aim of this theorem is to verify the maximum power, when we will get maximum amount of power. Okay, the condition for maximum power is when R Thevenin's is equals to RL, then only maximum amount of power is transferred from source to load. Now see here, when load resistance value is 0 kilo ohm, okay, then load current IL value will be 5 by RTH plus RL, right? That is 2 kilo ohm plus 0, then IL value will be 2.5 milliamperes, then power is IL square into RL, RL value is 0, right? Then power will be 0. Okay, just see the tabular form here. Here V Thevenin's value is common for all voltage, that is common 5 volts. R Thevenin's is also 2 kilo ohms, already calculated, right? VTH will be 5 volts and RTH value is 2 kilo ohms. Next, here RL is equals to 0 kilo ohm, IL value is 2.5 milliamperes, right? Okay, 2.5 milliamperes, and power will be 0. Here RL will be 0 kilo ohms, right? Next case, when load resistance is 0.2 kilo ohm, right? IL value will be 5 by 2 plus 0.2, then IL value will be 2.27 milliamperes, and power is IL square into RL, that is power value will be 1.03 milliwatts, right, for second reading. Next, when RL is equals to 0.4 kilo ohms, IL value will be 5 by 2 plus 0.4, that is IL value is 2.08 milliamperes. Power will be IL square into RL, that is 1.73 milliwatts. Okay, here RL value is 0.2 kilo ohms. Sorry, here already kilo ohms is mentioned, right? 0.4. Then previous cases 0 for 0.2, 2.27 and 2.08, right? 2.27 milliamperes, 2.08 milliamperes, right? Next, RL is equals to 0.6 kilo ohm and power, then IL is equals to 1.92 milliamperes and power P is equals to 2.21 milliwatts. That is for 0.6 kilo ohm, IL value as 1.92 and power is 2.21 milliwatts. Your load power units will be in milliwatts. Okay. Next, similarly RL is equals to 0.8 kilo ohm, then IL equals to VTH by RTH plus RL, that value will be 1.78 milliamperes. Power is 2.53 milliwatts, right? 1.78, that is for 0.8 kilo ohms. Current is 1.78, power is 2.53 milliwatts. Similarly, when RL is equals to 1 kilo ohm, IL is 1.66, right? And power P is equals to IL square into RL, that value will be 2.75 milliwatts. Okay, similarly RL is equals to 1.2 kilo ohm. Okay, when RL is equals to 1.2 kilo ohm, IL value is 1.56, right? Power value will be 2.92. when RL is equals to 1.2 kilo ohms, right? Next, when RL is equals to 1.4 kilo ohms, IL value is 1.47 milliamperes and load power is 3.02. When RL is equals to 1.4 kilo ohms, right? IL value is 1.47 milliamperes, right? Power value is 3.02. Next, when RL is equals to 1.6 kilo ohms, load current IL value will be 1.388, right? And power is 3.08 milliwatts. Similarly, when RL is equals to 1.8 kilo ohms, right? IL value will be 1.315. Next, load power value will be 3.11 milliwatts. Okay, next case, when RL is equals to 2 kilo ohm, IL value will be 1.25, load power will be 3.12 milliwatts, right? Next, when RL is equals to 2.2 kilo ohms, IL value is 1.19 milliamperes, then power is 3.115. Okay, next, similarly, when RL is equals to 2.4 kilo ohms, here IL value is 1.13 milliamperes and VL value is, power PL value is 3.06. Okay, after that RL is equals to 2.6 kilo ohm, IL value is 1.08, right? Power P value will be 3.03. Power P value will be 3.03 milliwatts. Similarly, when RL is equals to 2.8 kilo ohms, load current IL value is 1.04, load power is 3.02. Load power is 3.02 milliwatts, right? Similarly, when RL is equals to 3 kilo ohms, okay, when RL is equals to 3 kilo ohms, IL value will be 1 milliampere. Okay, IL value is 1 milliampere and load power will be 3 milliwatts. Okay, when similarly RL is equals to 3.2 kilo ohms, IL is 0.96 milliamperes and load power is 2.94 milliwatts. Okay, next, when RL is equals to 3.4 kilo ohms, IL value is, see here, IL value is 0.92 milliamperes. Then load power value is 2.9 milliwatts. Similarly, you can calculate for up to RL is equals to 3.6, 3.8, 4 kilo ohms. Okay, now observe the load resistance versus load power. Okay, load resistance versus load power. See here, when RL value is 0 kilo ohm, load power is 0. RL is 0.2 kilo ohm, load power is 1.03. 0.4, power increases. 0.6, 2.21. 0.8, 2.53, right? 1, 2.75. 1.2, 2.92. 1.4, 3.02. 1.6, 3.08. 1.8, 3.11. At 2 kilo ohm, 3.12. Now you can observe this here 5 volts, right? V Thevenin is 5 volts, R Thevenin is 2 kilo ohm. That is common for all readings, right? Now you can observe this reading. Okay. The statement of maximum power transfer theorem is maximum amount of power is transferred from source to load when source resistance is equals to load resistance or RTH is equals to RL, then only maximum amount of power is transferred from source to load. Now you can observe here RTH value is 2 kilo ohm, RL value in kilo ohms, right? RTH is equals to 2 kilo ohm and RL value is 2 kilo ohm, right? Here when RTH is equals to RL, then only we will get maximum power. You can observe all the readings, right? From RL is equals to 0 to 2 kilo ohm, power is increases. When RTH is equals to RL, then only we will get maximum power. After that, power is slightly reduces. See here, for 2.2 kilo ohm, 3.115, 2.4, 3.06, 2.6, 3.03, 2.8, 3.02. That means if we draw the graph between load resistance RL versus power P, you will get the graph like this. When RL is equals to RTH, then only you will get the maximum power, P maximum. Okay, from RL is equals to 0 to up to RL is equals to RTH, what happened? Power increases. When RTH is equals to RL, from these readings, when RTH is equals to RL, then only we will get the maximum power. After that, power is slightly reduces. Okay, that is about maximum power transfer theorem. Okay, thank you all.